Hello, today we are going to go over the test review. So if you just have a specific question, you probably can go ahead and fast forward to that, but I'm going to be going through every single problem. I would make sure you know this review forwards, backwards, sideways, diagonally, every way possible, because this is going to be very similar to the test. If you can do the problems on this review, you're going to be able to do the problems on the test. So, on the first one, we can solve the linear set of linear equations using any method. Well, what I notice right away is I have a negative 6x and a positive 6x. Those are opposite coefficients. So I'm going to just go ahead and add those two equations together. And what happens are the 6 and negative 6 cancel. 5y plus 4y is 9y. 1 plus negative 10 is negative 9. Divide both sides by 9, and you get y equals negative 1. Well, that's half of my answer right there. I don't know the x-coordinate, but I know the y-coordinate is negative 1. I need to know the x-coordinate. It doesn't matter which equation I plug it into. I'm going to plug it into the bottom so I don't have to deal with that negative sign. So 6x plus 4 times negative 1 equals negative 10. All I did was I took out the y and put in negative 1. 6x minus 4 equals negative 10. Add 4 to both sides, and you get 6x equals negative 6. Divide by 6. X is going to be negative 1. Now, if you wanted to go back and verify your answer, negative 6 times negative 1 plus 5 times negative 1 should equal 1, which it does. 6 times negative 1 plus 4 times negative 1 should equal negative 10, which it does. So I'm going to go ahead and box up that answer. We're done. On number 2, I have the same coefficient, negative 2, negative 2. What I'm going to do is I'm just going to multiply this bottom equation or the top equation by negative 1. It doesn't matter which one. But when I do that, it changes the sign of every term. So I'm going to make all of those plus. Now I have a positive 2 and a negative 2. I can add those together. 7x plus x is 8x. 13 plus 11 is 24. You divide both sides by 8, and you get x equals 3. Well, that tells me half of my solution. So I'm going to go ahead and plug that in. I think I'm going to do the bottom equation. Take out the x, put in 3 minus 2y equals 11 minus 3 from both sides. Negative 2y equals 8. Divide by negative 2. Y equals negative 4. So my solution is 3 times, or 3 comma, negative 4. All right, on number 3, what jumps out on me right away is I have one of those variables solved for. I have y equals. As soon as you see one of those variables solved for, you should probably think substitution. So I know what y equals. Y equals 5x minus 3. So I'm going to substitute it in right there. So go ahead, rewrite that bottom equation. 3x minus 8y equals 24. But remember, we're not writing y, we're writing 5x minus 3. Be really careful. It's easy to make a mistake with that sign. We're going to distribute 3x minus 40x plus 24 equals 24. These x's are on the same side of the equal sign, so combine them. Negative 37x plus 24 equals 24. I'm going to minus 24 on both sides, and I'm going to do this one mentally, because I know 24 minus 24 is 0, 24 minus 24 is 0. So negative 37x equals 0. Divide both sides by negative 37. And I get x equals 0. Well, there's half of my answer. I just need the y-coordinate. And on this one, I think that top equation is going to be a lot easier because that y is already solved for. We know 5 is 0. Just do the math, and you get y equals negative 3. There's my solution. Number 4. Oh, number 4 looks like it might be a tough one. Tell you what, I'm going to probably need a little extra room, so I'm going to white some of this writing out. All right. Well, what I notice right away is I don't have any opposite coefficients. But I'm thinking elimination because my x's are lined up, my y's are lined up, my numbers are lined up. I might have to multiply 2 times. So I'm going to go ahead and eliminate my y's. I'm going to multiply that first one by 5. And when I do that, I get 15x minus 10y equals 2. It doesn't equal 2. Let's try that again. I almost made a mistake. Has to be every single time. 5 times 2 is 10. You might be asking, well, why did I choose 5? Because 5 is the coefficient of that other equation. So I have a negative 10 right there. Ask yourself what the opposite of negative 10 is. Positive 10. So I'm going to multiply that bottom equation by negative 2, because that'll create opposite coefficients. If I just did 2, I would end up with the same coefficient. I want opposites so they cancel out. And when I do that, I get negative 10x plus 10y equals negative 20. Well, I have opposite coefficients now, so I'm going to go ahead and add those together. 15 plus negative 10 is 5x. Negative 10 plus 10 is 0. 10 plus negative 20 is negative 10. Divide both sides by 5. X is negative 2. Well, now we need to know y. So I'm going to go and I think I'm going to put it in the top equation. 3 times negative 2 minus 2y equals 2. Well, 3 times negative 2 is negative 6. Add 6 to both sides. I get negative 2y equals 8. Divide by negative 2. Y equals negative 4. So my ordered pair there is negative 2, negative 4. Oops, I almost forgot part of my parentheses. All right, number 5. Again, notice right away you've got that y equals. That should say substitution. So I'm going to take that and put it where I see a y. Rewrite the equation. 6x plus 6y equals negative 6. But I'm not going to write y. I'm going to write in negative 5x minus 13. I'm going to make sure I distribute. 6x minus 30x minus 78 equals negative 6. Those are on the same side of the variable, so negative 24. Oops, I almost forgot my x. Negative 24x. Now let's write that a little better. Minus 78 equals negative 6. Add 78 to both sides. Negative 24x equals 72. Divide by negative 24. It's supposed to be a 4. Sorry for the bad handwriting. And you get x equals negative 3. Again, that tells me half of my answer. I need to know the y coordinate. I'm going to plug it into that second equation. So y equals negative 5 times negative 3 minus 13, which would give me 15 minus 13 is 2. So my answer is negative 3, comma 2. All right, we want a graph. Well, on number 6 here, I only have an x. If I only have an x, that's going to be a vertical line. And I'm just going to go put a dot on my x-axis at negative 2. I know it's going to be dotted because there's no equal sign with it. And then I have to do my shading. And that is a greater than. So as soon as I see greater than, I think bigger. So I know everything needs to be bigger than negative 2. So I'm shading the side where the numbers, my x numbers, are bigger than negative 2. And it should look something like this. On number 7, that is going to be a line because it's in slope-intercept form. Y equals mx plus b would be the boundary line. My y-intercept is 2. So put a dot at 2. My slope is negative 2, and I'd like to make that into a fraction. So I'm going to go down 2, right 1. If I wanted to, I could think of that as 2 over negative 1, and I could go up 2, left 1. Either way is going to get me the same line. Let's go ahead and do it. Down 2, right 1, or I could go up 2, left 1. Notice they're going to land on the same line. This time it's going to be solid because I've got that equal to. So I'm going to do my best to do a solid line. Now comes the fun part, the shading. Well, that's a less than sign, so that means I want to go lower. So that's going to be underneath. And everything that is shaded is going to be part of the solution. So 0, 0 is part of the solution, negative 2, 2 is part of the solution, 2, negative 3 is part of the solution. However, 2, 2 would not be part of the solution because it's not shaded. All right, number 8 is very similar. Um, the difference is you're going to be graphing two lines. Let's do the first one in red. And my y-intercept is -4. So put a dot at -4. My slope is 3 over 1. So up 3, right 1. Up 3, right 1. And that is going to be a dotted line. Oops. Got off a little there, but I think you can kind of see it. And I'm going to shade real lightly. Oops. Maybe I will. I'm going to shade real lightly. That's a less than. So I want to go below the line. So I'm going to shade underneath. Let's do the next one in blue. There, my y-intercept is 3. So you put a dot at 3. My slope is -1 over 2, so down 1, right 2. Down 1, right 2. And that is going to be a solid line. And on that problem, I am going to be shading above, because that is a greater than. Now that I've got both of them shaded, I'm going to ask myself, is there a spot where the blue and the red are both shaded? And the answer is yeah, there is an area where they're both shaded, right here. And that's really my final answer. So I'm just going to take that and shade that in really dark. I meant to do that in black, but you can get the idea. That's where the shading overlaps. All right, let's go ahead and do another one, number 9. On that one, though, it's not in slope-intercept form. So I'm going to take 3x minus 2y equals -2. I'm going to subtract 3x from both sides. And now I'm going to divide by -2. And each term needs to be divided by -2. I'm going to kind of do this more mentally in my head. But if you need to write the steps out of showing the division, go ahead. Divide by -2. The negatives cancel. When I divide by -2 here, a negative divided by a negative is positive. And -2 divided by -2 is +1. So my y-intercept is 1. My slope is 3 over 2. And that's going to be a solid line. Oops. You know what? There's a trick to this, and I almost fell for it because did you see how I lost my inequality sign? Can't believe I did that. Whoops. Let's go back and erase those inequality or those equal signs and put in inequality signs. It's not really a mistake if you catch it. All right, so we started with a greater than or equal to. But when I divide by that negative, I have to flip the direction of that sign. So I need to shade underneath because that's now a less than. So I'm going to shade really lightly underneath. We're just going to do it with our pen this time instead of going to the crayon option. So that means that 0, 0 is part of the solution. And if I wanted to, I could test it out by putting 0, 0 in that first equation, and it works out. All right, let's do the next one in green. On that one, I have x minus 2y. And I'm not going to put an equal sign this time. I'm going to put a less than. And I'm going to think dotted line, subtract x from both sides. Divide each thing by -2, each term by -2. And remember, when you divide by a negative, your inequality sign has to flip. So I get y is greater than 1/2 x minus 1. Oops. Put a dot at -1, up 1, right 2. And this is going to be a dotted line. And that's greater than, so I need to shade above. All right, looks a little messy right now because it is a little messy. Now that I've got everything shaded, I'm going to ask myself, does the shading overlap any place? Yeah, right here. So I'm going to shade that real dark. And that would be my final solution. All right, the fun part. We're going to write a system of linear equations. Don't let this scare you off just because it is a word problem. All we're doing is writing the system. It doesn't say to solve it, it just says to write. So 2 students are going to go to the store and buy pencils and pens. And they gave us what variables to use: C for pencils, P for pens. One of the students buys 2 packs of pencils and 3 packs of pens for $8.25. Well, that's easy. The number of packs of pencils, which is C, so 2C, plus 3 times the number of pens, 3P, for $8.25. Piece of cake. Now we do the same thing. Her friend purchases 5 packs of pencils and 2 packs of pens for $11. Well, 5 pencils plus the number of pens, 2 packs, equals $11. And again, it doesn't say to solve. All you're doing is writing the system. Let's do another one. You're buying plants, P, and soil, S. And I'll tell you right now, whenever I use S for a variable, I like to use the cursive S because my S's look too much like 5s. So if you see that with my handwriting, that's an S. The number of plants is 4 more than twice the number of bags of soil. You purchase a total of 10 items for your garden. Well, I'm going to start with you purchase a total of 10 items. So you know P plus S has to equal 10. Now let's do the one that's a little bit more complicated. The number of plants is 4 more than the bag of soil. So the number of plants is 4 more. So that means I'm going to be adding 4 twice. I'm going to be multiplying by 2. So 2 bags of soil plus 4. So again, it doesn't say to solve it, but if I were going to be solving this, I'd probably be thinking about substitution because that P is already solved for. All right, determine whether there is one solution, no solution, or infinitely many. Well, on this bottom one, -3x, -x. I want to create opposites. The opposite of -3 is +3. That means I need to multiply that by -3. I'm going to rewrite that top equation, -3x plus 3y equals 4. Distribute on that bottom equation, 3x minus 3y equals -9. The x's cancel, the y's cancel, and you get 0 equals -5. Now that's not true. So that is going to be a no solution. No solution. On the top one here, I've got 2x and I've got negative 4x. They're already opposite signs, but I want to make them opposite numbers, so I'm going to multiply that by 2. Rewrite by distributing 4x plus 6y equals negative 12. Rewrite the bottom equation, negative 4x minus 6y equals 12. Well, if you add everything together, you're going to get 0 equals 0. Well, everything cancels out, and 0 does equal 0. So that one is going to be infinitely many solutions. And our last one, I'm going to do that with substitution because that y is already solved for. So I'm going to plug it in, get 2x minus, excuse me, I need to back up and erase there just for a second. All right, I'm back. 3. Now instead of writing that y, we're writing negative x plus y. Let's go ahead and distribute. Be careful of that sign. 2x plus 3x minus 3y equals negative 21. Combine your like terms. Oh my gosh. I almost made a horrible mistake. Did anybody notice what I did? I think I got distracted. And I put a y instead of a 7. So that should have been minus 21. All right, that looks a lot better. 5x minus 21 equals negative 21. You solve that, you're going to get x equals 0 and y equals 7. So it's going to be one solution, 0, 7. Looks like the directions got cut off here. That's fine. Match the method for solving with the correct description. All right. Both equations are graphed. Well, that one's easy. I'm going to start with the easy one. That would be A. One equation has a lone variable. That means it's solved for. That's substitution. You have an x equals or a y equals. And both equations have like terms lined up. Well, elimination. Here, we want to write a system of linear inequalities. Let's go with the solid line first. My y-intercept is 3. My slope, let's see, rise 2, run 3, and it's positive, is 2 over 3. So y, that would be 2 over 3x, plus 3. We have to figure out our inequality. I know it's going to have an equal sign because it's solid, but now I need to figure out greater than or less than. Well, it looks like the shading is above the solid line, so it would be greater than or equal to. Now let's do the next one, the dotted line. Right away I notice it's got a negative slope. So my y-intercept is 1 to negative 3. And my slope, it looks like I'm going up 1, 2, 3. Let's see. I counted wrong. It's 4. So my slope is up 4. 1, 2, 3, 4 over 3. So y negative 4/3 x minus 3. And let's figure out our direction of our inequality. It looks like I'm shading above again. So that would be just a greater than. So there's my system right there. All right, number 17, our last one. True or false? A given system's problem can only be solved using one method. If you choose the wrong method, you won't be able to get a solution. False. One method might be a lot easier than the other, but graphing, substitution, and elimination will all give you the same result. All right, hope you enjoyed.